When dealing with wireway fill capacity, it's crucial to understand how the National Electrical Code, or NEC, governs the allowable fill for conductors and any splices within the wireway. The question specifically addresses the scenario where both conductors and splices are present, asking whether the 75% fill limitation for splices applies to the total cross-sectional area of the wireway, or to the already limited 20% area designated for conductors. The correct interpretation, according to the NEC, is that the 75% fill limitation for splices is applied to the 20% figure allocated for conductors. In simpler terms, you first determine the allowable area for conductors, which is 20% of the wireway's cross-sectional area. Then, if you have splices, the total area occupied by those splices cannot exceed 75% of the 20% conductor area. This tiered limitation ensures that the wireway is not overfilled, which could lead to overheating and potential safety hazards. The NEC provides detailed guidelines on wireway fill to prevent such issues. Overfilling the wireway can impede heat dissipation, potentially damaging the conductors and insulation. This can lead to short circuits, ground faults, and even electrical fires. Furthermore, an overfilled wireway makes it difficult to perform maintenance or make changes to the wiring system in the future. The NEC specifies different fill percentages for various types of raceways and wireways, depending on factors like conductor size, insulation type, and the presence of splices. Understanding these requirements is essential for safe and compliant electrical installations. The 20% fill limitation for conductors in a wireway is intended to provide adequate space for heat dissipation and to facilitate the pulling and routing of conductors. This percentage is based on extensive research and testing to determine the optimal balance between conductor capacity and thermal performance. When splices are introduced, they take up additional space and can further restrict airflow. That's why the 75% limitation on the 20% conductor fill area is imposed. This ensures that the splices do not unduly compromise the wireway's ability to dissipate heat. To accurately calculate the allowable fill for conductors and splices, you'll need to know the dimensions of the wireway, the cross-sectional area of the conductors, and the volume of the splices. The NEC provides tables and formulas to assist with these calculations. It's important to consult the latest edition of the NEC for the most up-to-date requirements and guidelines. Let's consider an example to illustrate how these calculations work. Suppose you have a wireway with a cross-sectional area of 10 square inches. The allowable area for conductors would be 20% of 10 square inches, which equals 2 square inches. Now, if you have splices in the wireway, the total area occupied by the splices cannot exceed 75% of the 2 square inches conductor area, which is 1.5 square inches. Therefore, the conductors must fit within 2 square inches, and the splices must fit within 1.5 square inches. In addition to the fill limitations, the NEC also specifies requirements for the type of conductors and splices that are permitted in wireways. For example, some types of conductors may not be suitable for use in enclosed raceways due to their heat-generating characteristics. Similarly, splices must be properly insulated and protected to prevent short circuits and ground faults. It's crucial to select conductors and splices that are specifically listed and labeled for use in wireways. This ensures that they meet the necessary safety standards and performance requirements. Furthermore, the NEC requires that wireways be installed in a neat and workmanlike manner. This means that the wireway should be properly supported, grounded, and protected from physical damage. Conductors should be neatly arranged and properly terminated. Attention to detail during installation is essential for ensuring the long-term reliability and safety of the electrical system. Improperly installed wireways can create hazards and increase the risk of electrical failures. When working with wireways, it's important to follow all applicable safety precautions. This includes wearing appropriate personal protective equipment, such as gloves and safety glasses, and energizing the circuit before performing any work. Working on live electrical equipment can be extremely dangerous and should only be done by qualified professionals. Regular inspection and maintenance of wireways are also important for ensuring the continued safe operation. This includes checking for signs of damage, corrosion, or overfilling. Any issues should be promptly addressed to prevent potential problems. By understanding and adhering to the NEC requirements for wireway fill, you can ensure that your electrical installations are safe, reliable, and compliant. Remember to consult the latest edition of the NEC and seek guidance from qualified professionals when necessary. The NEC, which stands for National Electrical Code, is a comprehensive set of standards and guidelines for electrical installations in the United States. It's developed and maintained by the National Fire Protection Association, or NFPA, and is updated every 3 years. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It's intended to protect people and property from electrical hazards. Compliance with the NEC is often required by law, and it's essential for ensuring the safety and reliability of electrical systems. The NEC is divided into chapters, articles, and sections, each addressing specific aspects of electrical installations. It contains detailed requirements for conductors, raceways, enclosures, and other electrical equipment. It also includes tables, charts, and examples to help clarify the requirements. To effectively use the NEC, it's important to understand its organization and how to navigate its various sections. The index is a valuable tool for finding specific information. It's also helpful to attend training courses and workshops on the NEC. These courses can provide a deeper understanding of the code and its practical applications. The NEC is not a static document. It's constantly evolving to reflect changes in technology and industry best practices. The NFPA solicits input from a wide range of stakeholders, including electrical engineers, contractors, inspectors, and manufacturers, to ensure that NEC remains relevant and effective. The process of updating the NEC involves extensive research, testing, and public comment. Proposed changes are carefully reviewed by technical committees, and the final version of the NEC is approved by the NFPA membership. It's important to stay up to date with the latest edition of the NEC to ensure that your electrical installations comply with the current requirements. Many jurisdictions adopt the NEC as law, making it legally binding. Failure to comply with the NEC can result in fines, penalties, and even legal action. In addition to the legal requirements, complying with the NEC is also a matter of ethical responsibility. As an electrical professional, you have a duty to protect the safety of the public and to ensure that your installations are reliable and safe. The NEC provides a framework for achieving these goals. The NEC also addresses the specific requirements for different types of electrical installations, such as residential, commercial, and industrial. Each type of installation has its own unique challenges and requirements, and the NEC provides tailored guidance for each. For example, the NEC has specific requirements for wiring methods in residential dwellings, such as the use of non-metallic sheath cable, or NM cable, and ground fault circuit interrupters, or GFCIs, in bathrooms and kitchens. In commercial buildings, the NEC addresses issues such as emergency lighting, fire alarm systems, and high-voltage installations. In industrial facilities, the NEC covers topics such as hazardous locations, motor control centers, and process control systems. The NEC also includes requirements for renewable energy systems such as solar photovoltaic or PV systems and wind turbines. These systems are becoming increasingly common, and the NEC provides guidance on their safe and reliable installation. The NEC addresses issues such as overcurrent protection, grounding, and disconnecting means for renewable energy systems. It also includes requirements for connecting these systems to the electrical grid. When working with electrical systems, it's important to understand the difference between the NEC and other standards and regulations. The NEC is a comprehensive code that covers a wide range of electrical installations, but it may not address all specific situations. Other standards, such as those developed by the Institute of Electrical and Electronics Engineers, or IEE, and the American National Standards Institute, or ANSI, may provide additional guidance on specific topics. It's also important to be aware of local building codes and regulations, which may impose additional requirements beyond those specified in the NEC. In some cases, local codes may be more stringent than the NEC. The NEC is a valuable resource for anyone involved in electrical installations. By understanding its requirements and following its guidelines, you can ensure that your installations are safe, reliable, and compliant. Remember to consult the latest edition of the NEC and seek guidance from qualified professionals when necessary. The wireways function is to protect and route electrical conductors. The NEC specifies that wireways must be supported at intervals not exceeding 5 feet unless specifically approved for greater distances. This support requirement ensures the mechanical integrity of the wireway and prevents sagging or displacement, which could damage the conductors inside. Furthermore, wireways must be securely fastened to the supporting structure using appropriate hardware. The type of hardware used will depend on the material of the wireway and the supporting structure. It's important to select hardware that is compatible with both materials to prevent corrosion or other forms of deterioration. The NEC also addresses the grounding requirements for wireways. Wireways must be properly grounded to provide a low impedance path for fault current. This helps to protect against electrical shock and reduces the risk of fire. The grounding conductor must be sized appropriately based on the size of the conductors inside the wireway. The NEC provides tables and formulas for determining the correct grounding conductor size. Wireways must also be protected from physical damage. This can be achieved by installing them in locations where they are not likely to be struck by vehicles or other equipment. If wireways are installed in exposed locations, they may need to be protected by barriers or guards. The NEC also specifies requirements for the labeling of wireways. Wireways must be clearly labeled to indicate their voltage rating, current rating, and other important information. This helps to ensure that workers are aware of the hazards associated with the wireway and that they take appropriate precautions. The labels must be durable and legible and must be securely attached to the wireway. When installing conductors in a wireway, it's important to follow the NEC requirements for conductor bending radius. The bending radius of a conductor is the minimum radius to which it can be bent without damaging the insulation. The NEC specifies minimum bending radii for different types of conductors. These requirements are intended to prevent stress and strain on the conductors, which could lead to premature failure. The NEC also addresses the issue of conductor derriting in wireways. Conductor derriting is the reduction in the allowable ampacity of a conductor due to factors such as ambient temperature and the number of conductors in a raceway. The NEC provides tables and formulas for calculating conductor derriting factors. It's important to apply these derriting factors to ensure that conductors are not overloaded. The NEC also includes requirements for the use of splices and taps in wireways. Splices and taps must be made in accordance with the NEC requirements and must be properly insulated and protected. The NEC also specifies the types of splicing methods that are permitted in wireways. It's important to use splicing methods that are listed and labeled for use in wireways. The NEC also addresses the issue of access to wireways. Wireways must be accessible for inspection, maintenance, and repair. The NEC specifies minimum clearances around wireways to allow for safe and easy access. It's important to consider these clearance requirements when designing and installing wireway systems. In addition to the general requirements for wireways, the NEC also includes specific requirements for different types of wireways, such as metal wireways, non-metallic wireways, and auxiliary gutters. Each type of wireway has its own unique characteristics and requirements. It's important to select the appropriate type of wireway for the application. Metal wireways are typically used in industrial and commercial applications where strength and durability are required. Non-metallic wireways are often used in residential and light commercial applications where corrosion resistance is important. Auxiliary gutters are typically used to supplement wiring spaces at meter centers, distribution centers, switchgear, and similar locations. The NEC also includes requirements for the use of wireways in hazardous locations. Hazardous locations are areas where flammable gases, vapors, or dust may be present. The NEC specifies the types of wireways that are permitted in different types of hazardous locations. It's important to select wireways that are specifically designed and listed for use in hazardous locations. Installation of wireways in hazardous locations must also comply with the NEC requirements for grounding, bonding, and sealing. These requirements are intended to prevent explosions and fires in hazardous locations. The NEC is a complex and comprehensive code, and it's essential to have a thorough understanding of its requirements to ensure safe and compliant electrical installations. Remember to consult the latest edition of the NEC and seek guidance from qualified professionals when necessary.